So by the end of this, you should be able to find functions, polynomial functions based off of some data that you're given. Okay? So everyone has this example, right? Okay, I just want to make sure I copied the right one. An oil tanker collides with another ship and starts leaking oil at a rate shown in the table. Write a polynomial function to model the set of data. So we have this data here that's time with an H. What do you think H represents? The hours. Okay? So as the hours increase per every hour, this is the rate flow which the tanker is losing, is leaking oil. Okay? So what we're going to do is we're going to create a scatter plot of the data and determine the type of polynomial function that can be used to represent this data. Because by looking at this, I mean, we can probably get an idea of what type of polynomial this is, but we want the most accurate one. Okay? So what we're going to do is we're going to go into our calculator, and there's a certain list of steps that we're going to do to actually get this graph. So what you'll need to do is you'll need to go to the stat button, which is located 2 buttons from your alpha button. The stat button. Okay? And then you should have these options on your screen. If at any point in time you fall behind, you need to let me know. Okay? So we're going to go right here to number 1, edit. We're going to click enter. And you should have L1, L2, L3 in your calculator. Okay? Does anybody not have L1? What about L2? Okay, cool. Because the thing is, you need to have all of these lists, basically. If at any point in time your L1 or your L2 is missing, okay? The reason why it's missing is, say, I want everyone to do this. Go up to where L1 is highlighted and click the delete button. It's gone. Now, this will happen because the student might say, okay, I want to go ahead and delete all the information that's in the list. You don't want to delete it, you want to clear it. So let's just say you accidentally deleted it. It's fine. All you do is you go back to your home screen. Second mode takes you back to your home screen. Click Stats. Go to option 5, Setup Editor. And then click Enter twice. It should say done, right? When you go back to Stat and you go back to Edit, it's back. Okay? So if you ever accidentally delete one of your lists, Setup Editor brings it back. Okay? Now, if your lists are not cleared out, they should be empty. All you do is you go up, make sure L1's highlighted, click clear, and enter, and it should clear it out. Okay, so I want empty list. Everyone okay? So in L1, we're going to type in our data for our time, our very top row. And then in L2, we want to type in our data for flow rate. Okay? So everybody go ahead and do that now. Type in your data. All you do is you click 1 and press enter. Click 2, press enter. Okay? So you just enter in your data. All the way up to 10. And you gotta make sure you click enter so that the calculator inputs in 10. Everyone okay? Now move the arrow over to L2, and now you want to type in the rate flow. Okay, that's L2. So we're gonna type in that data. Okay, so you see typing. So all your data should be in. Double check it just to make sure you didn't make any errors, because the smallest error is going to change everything. Good? Raise your hand if you need more time. Hold it. Okay. So go back to your home screen. How do you go back to your home screen? Second mode. Okay? So all your data is in there. Now, it says to create a scatter plot. Okay? We're going to do this on our calculator. All right? So go to y equals. Sorry, that we don't need that. Go move your arrow up so that it's blinking over plot 1 and click enter. So that way it's actually on. It should be highlighted. Okay? Now before you click graph, you actually have to let the calculator know that I want to see my data. So you're going to press zoom, and you're going to go down to option 9, zoom stack, okay? And what it should do is graph your data. Raise your hand if you do not have this. So, what type of polynomial does this look like? Out of all the polynomials that we know, out of all of our parent functions that we know, what does this look like to you guys? A square root? Okay, real quick, let's review what our parent functions look like. Actually, open up your foldable, okay? And let's re-look at our parent function. So what is this? What does this look like?
Quadratic.
It's a quadratic. And if you're having a difficult time trying to see this, okay, think about it. The only function that can actually go through would be a quadratic, okay? Quadratic. That opens how? Down. Which means that A is what? Positive or negative?
Negative.
Negative. Okay, so we should know, we should be able to see that. So in A, it says create a scatter plot of data and determine the type of polynomial function. So we know it's going to be quadratic, and we're going to do just a quick sketch of this data, okay? So here, what I want you guys to do is I want you to make a quick sketch of this data, make a scatter plot, okay? So we make our scatter plot. We just want a quick little sketch, okay? Just to get a good idea of it, all right? And so yes, it looks like a quadratic. Curves up, goes down. If I had a grid, or if I was writing this straight down, it probably look a little nicer. Okay? What's that?
Piecewise.
No, not so much piecewise. They will look like two separate functions. Now, a couple of things about a scatter plot, okay? Scatter plot is different from a regular graph, okay? So, if you notice, instead of putting dots, what did I put? I put X's, okay? It's different from your standard graph where you would put points and you would connect a curve through those points, okay? So that's one distinct difference between a scatter plot. Also, it was just a scatter plot, not a curve that goes through all of those points, okay? So do realize that you should just have the X's, no curve that connects them, okay? So just be aware of that. So for part B, it's asking us to write a polynomial function to model the data set. Round the coefficients to the nearest thousandth. How many decimal places is that? 3. And then state the correlation coefficient. Now realize this is something that we do in the calculator, okay? So we'll go back to our calculator. To get the equation, go back to your home screen. What do I press? Second mode, okay? So what type of polynomial function did we say this was? Quadratic. So we're going to go to stat. We're going to go over to calc. And since we said that this was look like a quadratic, we're going to go down to option what? 5. Quadratic. And what the calculator is going to do is it's basically going to take the data that we have and create a quadratic function that best fits this data. So we're going to click enter on 5. And raise your hand if yours looks like mine. Okay. If yours does not look like mine, give me a second. I'm going to show you what you need to do for both of them, okay? So if yours looks like mine, you want to make sure that it says L1 in XY list, L2 in Y list. Don't worry about the frequency. And when it says store, reg EQ, you want to go down. You want to go down here. You want to click bars. Bars is located right beside the clear button. Go over to Y bars. Click enter on 1, which is function. And then click enter again for Y1. Okay, that's if yours look like mine. Raise your hand if yours look like mine.
That's mine.
Like the front screen looks like this. Okay, did you guys follow me?
Yes.
Did you type it in? Okay, cool. Alright, hold off. Don't get like it. Calculate. Yours does not look like mine. It just pops up quadratic. Okay? then what you need to do is you need to press second. You need to press the second button, then you need to press 1. When you do that, it should pop up at L1, correct? Okay. Then you need to press comma. Comma is located right above the 7 button. Then you're going to press second 2. And it should pop up at L2. No comma. And now your calculator, you have to do this. Go ahead and click enter. And yours is like mine. Go ahead, go down and calculate, and click enter. And what it'll pop up, did you guys get these numbers? There is your quadratic function.
I don't have the R.
All right, if you don't have R2, I'll show you in a second. Say again. It says to round to the nearest 1,000, which is 3 decimal places. So what's A? Negative. Okay, so we have negative 0.409 x squared, because that's the A, that's the coefficient for my x squared term. My B is going to be 2.762, so plus 2.762x. Then what?
16.267.
Very good. Plus 16.267. And that is our polynomial function that models this data set. All right? To find your correlation coefficient. Actually, we're going to skip that. We don't need that for right now. Come back to it when we get more to stats. Don't worry about that right now. Questions up to this point. Everything you need is in the stat area. Okay? Practice. It says use the model. In other words, use the equation that we came up with to estimate the flow rate in 10.5 hours. You're going to plug 10.5 in for what? In for x. Because remember, the x-axis representing your time. We know our time. We're trying to figure out our flow rate. Okay? So, we're going to plug in, not 10, 10.5. And we're going to get our answer. So, we got 0.1755. So, rounding to the nearest 1,000, what do we get? 1.76. Okay? Now, realize that if you're looking and comparing it to the data, that table said hundreds of liters per hour. So basically, it was in decimal form to represent the 100 liters per hour. So this is actually 17.6 liters per hour. Yes? Mm-hmm. So you would technically times this by 100 to figure out exactly how many liters per hour. Okay? So you could do that, or you could leave this 0.176. Last question. Says use the model to determine the approximate time the flow rate was 1,000 liters per hour. Okay? You gotta be careful. Yes? We need to change this into the decimal form because remember, flow rate was in 100 liters per hour. So we have to convert this by basically dividing by 100, which is 10. So we're going to plug 10 in for what? Plug 10 in for y and set it equal to our equation. You could very well move 10 over, use quadratic formula to figure this out. But let me show you a shorter way. Okay? So we plug in 10 for y because we're looking for our time, which is x. Okay? So we go back to our calculator. Now, if yours was like mine, when you click y equals, it transfers my entire function in there. But if you did not have the calculator that I had, this is what you'll need to do. Click y equals, go to bars, go over to y bars. No. All right, it slipped my mind, but I know it's gonna come back to me probably next period. So, since you guys wrote down the equation, correct?
Yeah.
All right. If you're unfortunate to not have a calculator like mine, it's fine. Go ahead and just type in your function into the y equals, okay? Go to y equals and type in your function, because you wrote it down. Okay, so go ahead and type that in, and then click graph. Okay, so type in the function that you wrote down for part B, and click graph. Okay? And it should be a quadratic that, it might not go through every single point, but it should at least touch or hit most of them. Okay? So you type in the function that you got in part B into y equals. And then once I figure out the shortcut way to put this and plug it in, I'll make a new video and I'll put it up. Okay? So, just to check, make sure you typed it in right, it should go through. And y2, go back to your y equals, and y2 type in 10 to represent the left side of the equation. And what you should have is you should have your quadratic and a straight horizontal line that intersects the quadratic. Do you guys have that? We're trying to figure out the time in which the rate flow was at 1,000 liters per hour, which is this intersection point. That's what we're trying to find. Okay? So to find the intersection point, you click second trace. I did teach you this part? Cool deal. You go to which option? 5 intersects. So I'm trying to figure out where those two curves intersect, and you click how many times? You click enter 3 times. 1, 2, 3. So after 8.55 hours, that is when my rate flow is at 1,000 liters.
So 8.5 hours?
So 8.5 hours, yes.
Would you still round it to 1,000? Decimal place or?
Yep. So x equals, or is about 8.5. So about 8.5 hours. It's about, it's an approximate. So after about 8.5 hours. Questions?
How'd you get it down?
Huh?
With 8.45, 8.5, still not around 5 or 6 hours. That's what mine is.
Well, it just depends on how big of our thing. Let's see. Are we getting